Okay, welcome to the lecture for research methods. Talking today about sampling, how to create a sample for a research study, and then also talking about some details regarding how to write the methods section of a paper or proposal. So some basics about sampling. Well, first of all, we need to start with just some basic definitions. Right? Frequently, you're interested in studying some population, right, which is a group of people or animals or even objects. But it's typically unrealistic to hope to gather data from every member of that group. Right? So if remember, like I said before, population isn't everybody or everything, but it is all members of a particular group. And usually you can't get all of the members of that group. If you get some members of the group, that's your sample, right? It's a subset of a larger group that we include as participants in our study. Most of the design decisions we've talked about so far have been primarily relevant to promoting internal validity. But your choices regarding the composition of your sample will mostly impact one aspect of external validity, and that being generalizability. Remember, external validity and generalizability aren't the same thing. Generalizability is one component of external validity, but it is the component that is affected, influenced by the decisions you make about your sample. So depending on how you go about recruiting participants to be part of your sample, and depending also on the final composition of your sample, will be more or less representative of the population that you're interested in making generalizations about. Obviously, you can imagine if you had every member of the population in your sample, it would be completely representative. If you had 99% of the population in your sample, it would still be pretty representative. Usually, we have a much smaller percentage of the population we're wanting to talk about in our sample, even as low as 1%. Right? But it still might be representative depending on how we draw that sample. But in terms of how important it is for the sample to be representative of the population, it depends on the goal of your study, like we've talked about before. If you're investigating whether or not one variable can affect another, then you may not really be worried about generalizability at this stage of the scientific endeavor. You may want to identify a relationship with one sample, maybe one that's not that representative, and then you can try to find that relationship again in another study, replicate your study with a different sample, and if you find the same effect with enough different samples, then the aggregate of all those studies may show that the finding is generalizable, even though not one individual study was all that generalizable. So again, it depends on the purpose of your study. But when having a representative sample is important to you, you still probably can't get a perfectly representative sample, right? That's because of the presence of sampling error. Sampling error is just a broad term for any differences between your sample and the population from which it came. Even with very large samples, there will be some sampling error. You can imagine there's a bucket of golf balls. 100 golf balls, and of those 100, 50 are red and 50 are blue. So those golf balls are your population. If you reached in blindfolded and picked out 10 golf balls, so now 10 golf balls are your sample, you might get 5 red and 5 blue, and this would be a perfectly representative sample, but you might also get 4 red and 6 blue, or 4 blue and 6 red, or some other combination. Right? If you did this an infinite number of times, replacing the balls each time, you would get an average of 5 red and 5 blue for your sample. But that average doesn't mean much for the one time you draw a sample. The one time you reached in and did it, the one time you sampled from population, you could get something really unrepresentative. You could get 9 red and 1 blue, not representative at all. It's unlikely, but it's still possible. And the smaller your sample, the fewer balls you take out, the more likely it is that it won't be representative of that population. Right? So sampling error is really impossible to eliminate unless you use the entire population. But as samples get large enough, the effects, the influences of sampling error decrease. But as you also read in your book, it also depends on how many variables there are that are affecting or influencing the dependent variable, the number of nuisance variables out there. The more nuisance variables there are, the bigger sample you're going to need. If you have a variable that's not affected by a lot of things, there won't be a lot of noise in the data where kind of pre-existing individual differences on the dependent variable won't be, there won't be a lot of them, then a really large sample may not be necessary. Okay, so now in terms of methods of sampling, random sampling is often thought of as a gold standard. And to do truly random sampling, you need to identify all members of a population of interest. And each member must have an equal probability of being included in your study. So if your population is fourth grade students in the United States, you need to find some database that has every fourth grader in the United States, right? So you can draw from that database to randomly sample. And the thinking is that, well, if you do that, you're going to get a representative sample. But as we know from our reading, randomness does not guarantee representativeness. As I said, as the number of nuisance variables goes up, it's harder to get representativeness, and as our sample size goes down, it's harder to get representative samples. So random sampling is good, but it's still not perfect. It's really, truthfully, rarely done because of expense, excuse me, expense and practical limitations. Now, you don't want to get a biased sample, right? And just because a sample isn't random doesn't mean it's necessarily biased. But you certainly could get a non-random biased sample if you're doing a study looking at attitudes toward gun control, and your population was all college students, but you went to collect your sample at a gun show, you're going to get a biased sample because it's probably not representative of all college students, people attending a gun show, and that's going to affect the variable you're looking to measure. But if you chose 2 or 3 colleges in the U.S. to send out surveys to, even though you didn't sample from all possible college students, that's not necessarily a biased sample as long as you chose those colleges randomly. Okay, so random sampling is good, but doesn't guarantee representativeness, and it's not typically done. Another type of sampling, stratified random sampling. So when you randomly sample different proportions of a sample from different strata, and the strata are based on some theoretically important variable. The idea of trying to make sure that you get people being representative on these important variables. So if some population you're interested in is 70% men and 30% women, if you just did random sampling from that population, you should get 70% of your sample men and 30% women, but you might not. So you could do stratified random sampling. So you're first going to identify people's level on some variable, in this case the variable being biological sex, and then you're going to sample from the strata to match the proportions in the population. So you would randomly sample from the men until you got 70% of your sample. If your sample was going to be 100 people, you would randomly select men until you had 70 men, and you would randomly select women from that population until you had 30 women. And if you did that, now your sample looks like the population, which may or may not be what you want to do. Right? If you do that, then the conclusions you draw from your study will be more generalizable to that population. But what if you're interested in gender differences? If you're interested in gender differences, then it's probably more important to get equal numbers of men and women in your study. Because if you have a smaller number of women, you have less power to identify the effect in women, and you have more power to identify the effect in men, and so you've got some disproportionality going in there that's going to affect your ability to draw conclusions about those two groups. Just like if you're doing a study, and when my high school, and when I went in South Texas, and you got a random sample of all the students in that high school, And in that, in your random sample, you had one student who was of Indian and Korean mixed heritage. You might think, okay, well, that's representative of that population because there aren't many people that went to my high school that were of Indian and Korean mixed heritage. So, oh, good, I've got a representative sample. But whatever you find from that study, does it generalize to people who are of mixed Indian and Korean heritage? Probably not, because there's just one person in the sample who had that background. So if you want to generalize to members of a group, make sure you have enough members of that group, even if they're a statistical minority in your population. So something to think about there in terms of both gender and ethnicity. Do you want equal numbers, or do you want it to be representative of the population? Depends on what conclusions you want to draw from the results. A related type of sampling to stratified random sampling would be cluster sampling. This is where you select respondents from certain areas only or certain time periods only. And it's kind of a cheaper way to try to approximate random sampling. So let's say you wanted to do a study of people in U.S. cities. So all people who lived in a city in the United States are members of your population. But you can't afford to do a big study and cover every city. So you do some cities. So you select some cities randomly. So you randomly select 5 metropolitan areas. And then within those 5 metropolitan areas, you get every single person in that city, in New York, in Minneapolis, in San Francisco, whatever, and randomly sample within each of those cities. So you randomly select the clusters, and then within each cluster, you randomly sample to try to avoid any kind of bias or to reduce the sampling error. The most common type of sampling, however, is convenience sampling, which, as the name implies, consists of available participants. It's convenient to get them because they're nearby. This is probably what most of you will do. You'll recruit subjects locally, probably, and that's perfectly fine. You just want to be sure if you use convenience sampling, you have to be careful about what statements you make about how the findings of that study might generalize to people from other areas who are different from your sample. That's why it's so important to describe clearly your sample and how you formed your sample. Okay. Related to this idea of sampling is the idea of power, which kind of overlaps between sampling and data analysis. But power, briefly, is the ability to detect a statistically significant relationship, and we talk about it because sample size plays a role. And there's been a big push in the field lately to recognize that most studies that are done are underpowered. They have too few participants to find significant effects, where there might really be an effect. There might be a relationship between variable A and variable B, but you don't have enough people to find it. Most of the time, you might, even if it's true, you would only find it maybe 20% of the time. You have 20% power. Right? So as I said, it's influenced by a couple things, including the one we can talk about, sample size. So generally, the larger the sample, the better. But the larger the sample, the more expensive it is, and the more time consuming. But as kind of a rule, a general guideline, a minimum of 20 participants per group. So if you have just kind of a real simple between group study where you have control group and experimental group. Right? You have 2 groups, have at least 20 in each of those groups for a total of 40 participants. 30 per group is better, but a minimum of 20 to have any kind of shot at power. So the bigger the sample size, the more the power. It's also influenced, though, by the number of variables you're trying to look at. Obviously, with more independent variables and more levels of independent variables, you have more groups. Like if you're doing a drug study and if you had control versus drug, placebo versus drug, that's just 2 groups. If you did placebo versus 10 milligrams versus 20 milligrams versus 30 milligrams, now that's 4 groups, and so you need more people. But also for the number of dependent variables you're looking at, you want to increase the number of participants to maximize your power, and also to to avoid something you may remember talking about in stats. Family-wise error rate, right? The inflation of type 1 error rate. So a general rule for that would be in terms of number of dependent variables you have and number of participants you have, a 15 to 1 ratio, 15 participants for every dependent variable you're looking at. So it's really important to choose your dependent variable or variables carefully. You don't just throw everything out there. No, I hope something catches. Make sure you just measure the things that are most important, most kind of theoretically indicated to show an effect of the independent variable. And then the last thing that influences power is the actual size of the relationship between variables in the real world, right? So sometimes a variable has an effect on another variable, but it's small, right? Your decision of which car to buy might be partially influenced by what color the car is, right? So if we studied that, we might find a small effect size for effect of color on likelihood of buying a car, right? And it's harder to detect small relationships. So you need even more power if you're looking for something that should have probably a significant but small relationship. Something that had a stronger, bigger relationship, like maybe the relationship between the price of a car and the likelihood of buying it, maybe it would be a larger effect size that we're predicting. Those are easier to find, and you don't need as many participants to find those big effects as you do small effects. And to get an idea of, well, is the effect I'm looking for large or small? Well, you either have a theoretical reason for believing it's large or small, or you have an empirical reason. You look at other research, people that have done similar studies, whenever they found effects, how big were the effects? And they should have reported an effect size. Was it small, medium, or large? And that'll give you an idea of how much power you need and how big your sample should be. Related to this topic is this idea of sampling of stimuli. Right, so it's a different application of this same logic. Typically, our focus is on having representative participating individuals in our study. But we can apply this logic to another component of method design, that being the stimuli we present to participants. If you're doing that, you may not be. But frequently, studies involve presenting research subjects with some stimulus or stimuli which they must make judgments about or react to. So maybe showing them a picture of a person and having them rate their attractiveness. Making them listen to a song and then rate their mood. Are you happy or sad after hearing that song? When we do this, so we present them with stimuli, we usually make some generalizations from our study about how people respond to some class of stimuli. We'll say, oh, well, people find attractive people to be less intelligent or more outgoing, whatever it is. Or that people find that slow-tempo songs make them feel sadder than up-tempo songs. Now, the degree to which these generalizations are valid, right, the external validity, depends not only on the characteristics of our sample, but it depends on the representativeness of the stimuli used in the study. Right? Maybe if we're doing some of the pictures, did I show pictures of people of different ethnicities, different ages, of different sizes? If not, maybe people's perceptions of attractiveness and how that relates to how intelligent I think somebody is only true for people who are natives of Alaska. Depends on how representative your stimuli are of the population of stimuli that you're wanting to talk about. So again, just kind of keep that in the back of your head that the same logic applies if you're doing this kind of thing in your study. Think about what stimuli you're going to use, and if they're not representative, be very careful about the statements you make about what the implications would be of your study. Okay. Now, let's move on to talking about components of the method section. The first component, which not all papers you read will have this, but I'd like for you to put it in yours, would be a design section. Okay? This is where you give kind of an overview of your study. A couple things that'll go here. The basic description that it'll be experimental, quasi-experimental, correlational. Most of you, it should be an experimental study for this class. And then a little more detail. If it's experimental to quasi-experimental, it's also either between subjects, within subjects, repeated measures, or a mixed subjects design. Right? And again, you'll notice, thinking about APA style stuff, between subjects design, between subjects is hyphenated because it modifies design, compound modifier. So what these things are, between subjects design is when a participant receives only one level of the independent variable. Like in a drug study, if you either are in the drug group or the placebo group, you're not in both groups. That's a between subjects design, as opposed to a within subjects design, where a participant receives more than one level of the independent variable. So maybe with rating photos, if the independent variable is attractiveness of someone in a photo, we want to know if people trust attractive or unattractive people more. You know, in a within subject design, you would rate attractive people and you would rate unattractive people in terms of how trustworthy they were. You would see both levels of the independent variable. If it were a between subject design, you would only rate one set of pictures. If you were a subject, if you were a participant, and some other participants would be in the other group, and they would rate the other types of pictures. They would get the other level of independent variable. So within subjects, you get both levels. Between, you only get one level. One type of within subjects design is the repeated measures design, and that's when not just kind of getting more than one stimulus. This is about measuring more than one time. Where think about like a drug study, where really there's one group of people, and we're going to measure those people. So we're going to measure you on the dependent variable at time 1 before you get the drug. So before the independent variable is introduce the independent variable, and then measure you again after you got the drug. So now you've got both levels of the independent variable. You were measured before drug and measured after drug, and the two levels of the independent variable are no drug and yes drug. So that would be repeated measure design, which is a type of within subjects. So if you're doing repeated measure design, you don't have to say a repeated measures within subjects design. That's redundant. You can just say a repeated measures design. And slightly complicating things then would be a mixed subjects design, and that only occurs when you have more than one independent variable, and one of the independent variables is within subjects, and the other independent variable is between subjects. Example might be you have two groups that are getting different levels of a drug. So maybe one group is getting 10 milligrams, and the other group is getting 20 milligrams. So drug level is between subjects variable. So you're not getting 10 and 20, you're just getting either 10 or 20. But if I then measure both groups before and after they get the drug, then time is a within subjects variable. And so I've got these two variables, measuring before and after, and I have these two groups. Now it's a mixed subjects design. Okay. So you need to identify what type of design you have, and then that can be done in one sentence. And then you identify and operationalize your variables, your independent variable or variables, and the dependent variable or variables. We should just kind of describe how you're going to operationalize them. Give you an example of how to do all this, and the design section can be 2 to 3 sentences usually. So here's one: a between subjects experimental design. So it's a between subject design and it's experimental design. I can run all that together. Between subjects experimental design will be used to examine the effects of caffeine on students' ability to concentrate. So right there, you know that my independent variable is caffeine, and my dependent variable is ability to concentrate. I don't have to say the independent variable will be. All I have to say is the effects of A on B. And when I do that, you know that A is the independent variable and B is the dependent variable. Right? So I've done all that. Now I'm going to operationalize my variables. I want to say, how am I going to manipulate the independent variable? What do I mean by caffeine? And then what do I mean by ability to concentrate? So what do I mean by caffeine? Half of the participants will be given a capsule with 10 milligrams of caffeine, and the other half of the participants will be given visually identical capsules that contain no caffeine. Right? So there's my independent variable operationalized, and now my dependent variable concentration will be measured using the Fiala concentration test. In the abbreviation and in the citation for the test. Now I've operationalized my dependent variable. And right here, I don't go into detail about what the Fiala concentration test is. All I say is that's how I'm measuring concentration. Later on in the material section is where I'll describe in detail what the Fiala concentration test measures, what the items are like, that type of thing. The design is just kind of briefly, here's how I'm measuring it, here's how I'm conceptualizing concentration, or whatever your dependent variable is, anxiety, happiness, whatever. Okay? So design section, pretty brief. And then the sample section, so design, so the methods is the big section, so intro followed by method, and then within the method are these subsections, design, and then sample being the next subsection. You want to indicate the number of participants that you're going to have, right? Because this is a future proposal, you haven't collected the data, and you want to be sure and at least identify the number of men and women. You may want to identify other numbers, but the minimum thing is the total number of participants and the number of men and women, or boys and girls, or male and female adolescents, whatever you have going on. Brief example, participants will include 100 elementary school teachers, should be teachers, not teachers, parentheses, 90 women and 10 men. Right? So you can probably imagine I'm doing some stratified random sampling there. So you want to talk about the number of participants here. You want to identify relevant demographics, and what demographics are are relevant will depend on your study. Maybe age, maybe ethnicity, maybe occupation, maybe year they are in school. Just depends on what your study is, what things are important that make this sample unique or different from some other sample. You need to identify how you would recruit participants. Flyers will be posted in hospitals or in schools or whatever, or maybe you're going to call numbers in a phone book or some directory. There's a teachers directories, church directories, school directories. Maybe you're gonna mail out surveys to all taxpayers in Bell County. Whatever. How are you going to get people into your? How are you going to recruit people to be in your sample? How are you going to ask them? How are you going to find people to ask them to participate? You identify that, and then you identify their motivation for participation. And you don't have to give them something, but you need to. If you do give them something, you need to say what you're going to give them, right? What kind of compensation are they going to get? All participants who agree, all individuals who agree to participate will be compensated with a $10 gift card to a retail store upon completion of study. Or if you don't give them anything, then you say participation in the study will be voluntary. Right? You need to say one of those two things. Either say it's voluntary or say what they're getting. You need to address that, because people will wonder, well, why would they participate in the study? Because it might influence their answers. People want to know that. And then last, you want to be sure in addressing the inclusion or exclusion criteria you're going to have. Are you going to let everyone who responds to your call participants be in the study, or do they need to meet certain criteria? For example, maybe they have to meet diagnostic criteria for major depressive disorder. It's kind of inclusion criteria, but they can't meet criteria for PTSD. It'll be an exclusion criteria. And there are different reasons for keeping people in and keeping people out, depending on, again, who you want to generalize to, and what variables might affect your dependent variable in a way that would make it hard to find the relationship you're looking for. So think about what criteria you would set. And just kind of one thing to note here, I've got this kind of laid out in bullets, but this and all other portions of the method section are in paragraph format, not bulleted lists. So think about it as being bullets, but you need to craft it into a narrative where you have a paragraph structure. The next would be the material section or measures section, and it's not the material / measures section. Pick one of those labels. If everything in the section is just measures of a dependent variable, then probably call it the measures section. If it's measures and some other stuff, then use the broader term of materials. But it doesn't really matter, just pick one of those terms. But you want to describe here all the measures, all the measured variables you have. So your dependent variable, if you have more than one dependent variable, how are you going to measure that? You need to describe those tools, and you may have if you have multiple of those, you may have subsections for those to organize those measures. But when you describe them, you talk about the psychometric properties of the tool. So if you're using the Beck depression inventory, you need to address its reliability and validity, and then cite where that information comes from. People write articles all the time about, okay, this instrument has good sound psychometric properties for this use, and they've gone and tried it on somebody and compared it to some other measure. Find those, cite that. Mental measurements yearbook is a good place to find that information. And briefly describe the measure. It's a 20-item self-report inventory that where participants are asked a series of questions, such as, give an example or two. Right? You don't have to repeat the whole measure, but enough information that people kind of get an idea of, okay, that's what this thing is like. I can imagine what people would be doing when they're completing this instrument. And then you also want to provide a citation for the published measure, so that if somebody wanted to redo your study, they could go look at that citation and find them themselves. And then if you have any special materials, be sure to describe those. If you have stimuli you're presenting to participants, pictures, you want to describe them, where you got them. If you have manipulatives, if you're having them do puzzles or something, you have to describe all that in detail. But you don't have to describe kind of basic common stuff like, if they're going to come into a room and fill out a questionnaire, you'd say, they will complete the questionnaires in a standard classroom setting. You don't have to say the desk will be 3 feet high and the chairs will be made of blue molded plastic. You don't have to go into that level of detail. That level of detail really only if you're doing kind of special or unique stuff where somebody would need to know, oh, okay, you used, flashes of light that lasted 3.7 seconds. That might be important. But you don't need to describe, there was fluorescent lighting in the room. You don't need that kind of detail. But again, any special materials, do describe those. The procedure section, which is probably the trickiest to write, because you have to try to anticipate everything that would go on in your study in terms of what these participants are going to experience, and get it down in a narrative format that flows as best you can. Some components that you want to be sure to address when we're talking about the procedure is group assignment. If you're in experimental design, how did people end up in either the drug group or the placebo group? If you use random assignment, be sure and say that. When and where will the study take place? And again, in terms of level of specificity, you don't need the exact time and address. If you're doing the study at 8 a.m. on a Thursday at North Campus, you don't have to say all that. So, research subjects will be directed to arrive at a university campus in the morning to begin their participation in the study. That's fine. But anything that's important in terms of the setting and when it will take place, how long it's going to take, what's given or done to participants. If they're given instructions, describe those instructions. If they're going to be debriefed, talk about that. And make sure in there you identify kind of the timing and sequence of events. So what will they do first? What will they do second? What will they do last? How long does each thing take? And you don't have to say they will read the informed consent, and it'll take approximately 6 minutes to read the informed consent form. You don't have to do that. But if they're going to be listening to or watching clips from sad movies, then you want to say how long they're going to be watching those clips. That's important information. So again, use kind of common sense about what's important and relevant information here. Okay. But for this section and overall for the method section, a couple of just kind of key points. One I've kind of already touched on is an appropriate level of detail. And the key thing is provide enough detail that someone else could recreate your study. And some details are non-essential, right? So, the experimenter will be wearing a blue shirt. That's probably not essential. But you need to decide what level of detail is essential to faithfully replicate your study. So what things are important if somebody wants to do your study again? What things do they have to know to be true to the spirit of your study if they wanted to find what you found again? And then anything else, if it's not essential, you don't need to go into that level of detail. Try to think about any potential confounds. So any differences between groups, if you have groups of people at receiving different levels of the independent variable, what are you doing to make sure those groups are as similar as possible other than the independent variable? And so take those steps, talk about those steps, and something that you won't necessarily typically do in a proposal or in a research paper, but I want you to do here, is explicitly address how you're going to account for internal and external validity. In at least two ways. I want you to say at least two things there, to ensure or to promote internal validity, or to ensure or promote external validity, blah blah blah, and say what you're going to do. And again, you typically wouldn't use that language, but I want to be sure you know why you're making the choices you're making and what impact they have on validity. And those things can happen in the procedure section. They might happen in the material section. They might happen in the sample section. Might happen in more than one section. But somewhere in the methods, you should have at least two sentences that clearly address internal and or external validity. Okay. All right. Again, main thing: appropriate level of detail. If you have to put it in bullet form first, that's fine. Make sure you have all the pieces, and then try to find some way to craft it into paragraph form.